Okay, in today's lesson, we're going to study some inverses. And we've done a lot of parent functions that are inverse pairs, and we're just going to reconnect them to today and bring out some characteristics that you may or may not remember. So look what's going to happen. We're going to graph each function and its inverse. We're going to state the domain and the range of using set notation. So maybe you need to remind yourself set notation is the one with the curly brackets. So look at what's going to happen. We're going to graph a line. This is review, just a linear function, and its inverse. Here we're going to graph a quadratic, but remember when you graph a quadratic, it has to be limited. The domain has to be limited for its inverse to exist. So we have to limit just to the right side. And then this is an exponential function. So we're going to be doing a lot of review on this. But before we do that, let's come back to these facts at the top. There are some characteristics that we said always are true of inverses. One is that the points invert. Okay, x and y of one function will be the x and y of the next function when you just swap them, and I'll show you how to do that. The other thing is that y equals x is the line of symmetry for all of these, on all the sets, okay? And then we'll come back and add some more. So let's just do line of symmetry really quick. I'm just going to go through these graphs and put in my line of symmetry just to save us some time later. All right, now that those are in, let's look at our graph, okay? We're going to graph this line with a slope of -1/2 and a y-intercept of -1. So I'm going to start here at -1. Slope of -1/2 means I'm going to go down 1 and over 2, down 1 and over 2. Then I'm going to use a straight edge and draw in this line as best I can on this thing. So this is my equation. This is y. All right. Now, let's look at these points. This is where I'm going to show you how to invert, okay? Let's just kind of zoom in and look at these points. This is going to be at 0, -1. This is at 2, -2. And this one is at 4, -3, right? So to get my new points, all I'm going to do is swap the x and the y of these. Now, hold up. Before we do that, let's come over and do domain and range of the y function, okay? I'm just going to keep them in blue. So the domain of this, where is our x? Well, remember the rule with domain, we just collapse to the x-axis. If it covers all the x-axis, it's going to be all real numbers, so it's an element of all real numbers. The range will be y is an element of, let's see, if I collapse this to the y-axis, everything's going to cover the whole y-axis because of those arrows, so it's going to be also element of all real numbers. All right, now let's invert our points. So 0, 1 is going to become, 0, -1 is going to become -1, 0. 2, -2 is going to be -2, 2. And then 4, -3 will be -3, 4. All right, so if I draw on my line, using my straight edge, this is my inverse function, so make sure to label, and look at that. Now let's do domain and range of the inverse. What about our x values? What's happening here? Okay, they both have arrows on both ends, so if I collapse all the way down to the x-axis, everything's covered. So x is an element of all real numbers. The range, collapse to the y-axis, notice everything's covered, so this is y is an element of all real numbers. Now, this one, if you look back at the original functions, domain and range, and the inverse, they're kind of all the same, right? So this isn't the greatest of examples, but maybe you remember the domain and range switch as we do this. And we'll see this more on the next example. Let's try number 2. All right, y equals x squared minus 2. So this is a quadratic. It's limited. Remember, it's limited. And remember, since it's greater than, that means it's the right side of the parabola that we're going for, okay? So let's put in some values, okay? If I put in 0 for x, I will end up with -2. If I put in a x of 1, it'll be 1 minus 2. That'll give me -1. If I put in, it goes 1, 1, then it goes 2, 4, right there. So there's the right side of my parabola. Okay, recall that. Now, let's do domain and range of this guy. So that my domain is, look, it's limited, right? It only starts where x is 0, and then it continues to get bigger. So x is greater than or equal to 0. The range, okay, from bottom to top, it goes from -2 up. So y is greater than or equal to -2. Now let's look at our points. What are our points here? We have 0, -2. We have 1, -1. And we have 2, 2. Now, if we invert our points, we're going to have -2, 0, -1, 1, and then 2, 2 is the same point, right? So look at this. Look at that graph. What does it remind you of? That is the square root graph, right? So this is I didn't label, did I? This is the inverse function, and this is the original function. Now look at that. That is the square root function. Now let's do domain and range. The domain of my inverse, look at this. The x values start at -2 and then they get greater. So it's x is greater than or equal to -2. And the range, it goes from 0 up. So y is greater than or equal to 0. Now, let's kind of zoom out for a moment and take some notes on what we've noticed. When we did the inverse of the linear function, notice it created another linear function, right? So let's come up here and write these inverse pairs in here that we've noticed. So if it was linear, the inverse of it creates a linear function. But look at our quadratic, number 2. When we inverted it, what did it become? Look, that's a square root function, right? It became the square root function. And then notice what happened with our domain and range. Look, the domain of my quadratic, it flips and becomes the range of my square root. And same thing with range to domain here. So the domain and the ranges invert as well, or they switch, however you want to say it. So domain and range switch for inverses. Now let's look lastly at number 3. This is an exponential. So we'll see what you remember about exponentials. Exponentials do have that asymptote. Let's look at this clip art really quick. Here's your exponential graph that we looked at. So let's remind ourselves. It has an asymptote where y equals 0. So as long as we're not moving up and down, that's going to stay at y equals 0. And these points are like at 0, 1, 1, 2, 2, 4. They go up exponentially. So knowing that, let's come back here and apply that to our graph. So look at this. Look what's happening to this, all right? So this is going to be moving what? Right 2 and up 3. So I'm going to move my origin, right 2, up 3, 1, 2, 3. And this is where my asymptote will fall for my exponential. And then remember with exponentials, we go we do this. We go at 0, 1. One, 2, and 2, 4. And then at -1, 1/2. So it makes that little tiny curve. So feel free to pull your pink notes out and remind yourself. So there's your exponential function. Remember that shape? Now, let's look at our domain and range of this. So my domain, let's see, x is, look at that. It's going all real numbers, isn't it? Arrows both directions, so x is an element of all real numbers. My range is limited because of the asymptote. So let's think carefully. Why? Okay, it can't cross my asymptote at 3, so it's going to be greater than 3. Can't be or equals to, it's just greater than 3, and it goes from there. Now we're going to invert. So let's look carefully at our points here. This was at 1, 2, 1, 2, 3, 4. So this is 2, 4. So this is 0.24. This one is 1, 2, 3, 4, 5, 3, 5. And this one is at 4, 7. So now when I go to invert this, remember this went up 3, our asymptote went up 3. That means I need to go right 3. So I need to move my asymptote right 3. It inverts, so y negative 1 is right 3. And then let's going to invert our point. So the first point will be at 4, 2. The next point will be at 5, 3. And the next one will be at 7, 4. So here's, oops. So my curve looks like this. All right, approaches that asymptote but does not cross it. Now let's go back. Now our domain of the inverted should match the range of the original. So x greater than, or x such that x is greater than 3. Now let's go back and look. Is that true? Well, we moved our asymptote to 3. It can't equal 3, so it's everything greater than 3. So that does work. It matched correctly. And the range, let's look at our range. The range should match the domain of the original, which was all real numbers. Well, it does go from bottom to top. There's arrows both directions, so it is all real numbers. So y such that y is an element of all real numbers. Okay, so what else do we need to add here to the top? Well, we need to add a couple things. One thing we said was that the asymptotes will switch. Okay, they switch from vertical to horizontal or vice versa. Now what else did we do? We did exponential, and when we inverted it, look at the shape, it became the logarithmic function. And then another one that we don't have on this page, but maybe you remember it, we did the cubic function. We did those on the same day, and when you invert it, it becomes the cube root function. Now these first three will be the ones that you see the most in pre-cal and calculus, but they're all inverses of one another, good to review. Let's look at the back and show you how the questions will be asked today. So, number 4, if f of x is equal to 3x minus 8 and g of x is the inverse of that, name the kind of function that g of x would be. So we're just naming. That's all we're doing. We're just naming on this one. Well, you got to know, what kind of function is this? Well, this is linear. And we said, well, when we inverse a linear, what do we end up with? Well, we said it comes out to be another linear function. If you need to, go back and look at example 1. Number 5 says, if f of x is the square root of x plus 2 and g of x is the inverse, state the domain of g of x. Okay, so maybe you remember the domain of g of x should be the same as the range of f of x. So what I would do is then come and sketch the graph. Okay, sketch the graph and find the range and then put it in terms of x for the domain of the inverse. So let's think about our graph here. This is a square root graph. And it is moving, what, left 2? So you don't have to be super detailed, but we know it needs to move left 2, so we know it has to do this, right? So what would our range be on this? Well, the range of this guy would be y such that y is greater than or equal to 0, right? It's not going below that x-axis. So to convert that to domain of the inverse, I just need to say d such that x is an element of, x is greater than or equal to 0. See what I did there? Found the range of the original and then changed it to domain for the inverse. Let's look at number 6. If f of x is 5 to the x power plus 9 and g of x is the inverse, state the domain. So again, I'm going to sketch this graph. Now, exponentials, remember, have an asymptote. And that asymptote usually is where y equals 0, but it's moving up 9. So I know that asymptote has to come all the way up here. So this is y equals 9. So if I think about, and that means it's going to be going this direction, right? Well, that means my range here was y is greater than 9. Can't be equal to, it's greater than 9. So when I convert to domain for the inverse, x, so the x is greater than 9. Okay, so you're going to do some thinking. Got to do some thinking. If the function f of x is log of x plus 5 and g of x is the inverse, state the equation of the asymptote. Interesting. Okay, so a logarithmic function Remember, logarithmic function has an asymptote that is vertical. So, but where is it? Well, it moves left and right, so that would move 1, 2, 3, 4, 5. Logarithmic would do this, right? It would look like that. So if this asymptote is at x equals -5, where's the asymptote for the inverse? Well, remember the asymptote switch. So if this is x equal to 5, if I switch it, it becomes y equals -5. So there's how you're going to switch your asymptotes, okay? Sign didn't change, it's just the orientation of it. Lastly, true or false? If f of x is the square root of x plus 2, and g of x is the inverse, then g of 3 equals 7. So what does that really mean? Well, if g of 3 equals 7, that means the input, the x, is 3, and the output, when you put it in the equation, comes out 7. So if that's g, then f of x would be the inverted values, right? So that would mean f of 7 should equal 3. Well, let's find out. We'd have to check that. So let's do that. F of 7, is it equal to 3? So let's see. If we plug in 7 into this equation, we'll have 7 plus 2. That's the square root of 9, which is 3. And it checks out. Yes. True or false is if f of x is square root of x plus 2 and g of x is the inverse, then g of 3 equals 7. That is a true statement, and that's how you check it. All right, I hope all this makes sense, and if you have questions, let me know when you get to class.